Hello. Hmm. No, I think it's fine. This is also fine. Okay. Uh, hey guys, welcome back to another live stream. I know I'm late, little, but I'm back. At least, hopefully, I'll try to be like on time from next time onwards. So today I'm little late. But today I'm thinking of going uh, to another live stream, uh, practicing DSA questions back where we belong. We'll try to improve as much as we can. This time again, just a second. Okay, great. So yeah, what I was thinking is uh, we'll try to, because I was not able to give the bi-weekly and weekly contest this time. So I was thinking of going through up solving those questions, and then we can go to Codeforces questions back, and then we'll start doing Codeforces questions. So this is what my plan is right now, and yeah, so this is how we will be uh, moving forward. So right now, let's try bi-weekly or weekly. Should we go for bi-weekly contest first or weekly contest first? Let's try for bi-weekly. We'll start from start and we'll go one by one. So going for the easiest one, I think I should start with the easier one. Let's go with the second one and third one, and let's see. I tried this question once, if I'm not wrong. I just only read the question, and I was thinking of some kind of approach at that time, but I didn't get the exact approach. So right now I'm thinking of like trying some approach. Okay, uh, let's see. Let's try to think in a better way. So earlier we were not thinking in a good way. So the question says, okay, let me open my. So the question says you're given an integer array nums and two integers k and num operations. Okay, let's look at this question. So we are given an integer array nums of and two integers k and num operations. You must perform an operation num operation times on nums. Okay, a single operation can be performed num operation times on nums, where in each operation what I have to do is select an index I that was not selected in any previous operations, add an integer in the range minus k to plus k to nums of I. Return the maximum possible frequency of any element in nums after performing the operations. Okay, so I like it's saying me that I have 1 4 5 as my nums array. I can do two operations, and in each operation what we need to do is we need to add, we can add or we can subtract k from that integer. So from 4 we can, if we subtract k, will be like 3 because k is 1 over here. If we add k, will be 5. So from 3 to 5 is the range that I can go for same 5. We have kind of range 4 to 6, and for 1 we have range 0 to 2. So now the range becomes 0 to 3 to 5 and 4 to 6. Now I need to know if any of them are overlapping kind of thing. If it is possible, then we are like towards a solution. So if we sort it in ascending order and we see if we are able to find the maximum overlapping interval. So if we see like 0 to 2 we have, 3 to 5 we have, 4 to 6 we have. So 0 to 2 is not overlapping with 3 to 5. So 0 to 2 is like a single interval. In 3 to 5, 4 to 6 is also overlapping, right? Okay. So there we can say we have two, this was actually a 4 and this was actually 5, right? And we converted it into interval, and then we are trying to find the maximum overlapping interval, right? I can see 2 is the maximum overlapping interval that we have over here. Now what if something is like this is 2, I can perform 2 operations. So I can say that okay, 2 if we perform one operation on this element, one operation on this element, it's possible to make a 2 size. So 2 operations can be done and we'll be able to find the answer. Now what if we are only allowed to do one operation? Then also we'll be able to form 2. Why? Because 3 to 5, 4 to 6, we can say that they are overlapping, but we may not do any operation on any one element. We may not do any operation on any one. So 4, 5, 6, 6 to 8. So they are also overlapping, but but will it like now they all becomes 3. There are 3 like kind of overlapping intervals, but if I see I will not be able to make this close to this because the range is like maximum 3 to 5 only. So like thinking of in a overlapping way is like not going to give me a proper solution because this 3 to 5, I can see this overlapping interval using the logic of overlapping interval will be able to find 3 intervals that are overlapping over here, but 3 to 5, 4 to 6 and 6 to 8 are not actually these 3 are can be overlapped with each other because this has a range of 3 to 5 only, and this is 6 to 8, which are different. I cannot make this somehow close between or overlapping with 6 to 8. So this is somehow a wrong way to approach this. Let's see. So whenever we have these interval kind of things, there are few logics only there which can be used, and means basic logics. So if kind of interval or ranges thing is there, we have range. We have range, but we can say we have two approach one, kind of merge interval, which comes option 2, using map, option 3 using line sweep. I'll go. So these are the like basic things whenever we go in a range kind of situation. These three should be applied and checked whether it is like possible uh, or not. If it is out of these three bounds, then we can say that we can like try some other things other than this, but most of the time it will fall into these three kind of situations. So maybe let's see line sweep algorithm, whether if it is like approachable or not approachable. So we have this 0 to 2, in between 0 to 2 interval we can say the values increased, and the maximum that we are going is 8. So uh, let's create a box of 0 1 2 3 4 5 6 7 8 and 9. So 0 1 2 3 4 5 6 7 8 9 and 10. Okay, one extra. Okay, no problem. So I start with 0. Everyone initially everything will be filled with 0. Let's say, so let's fill everything with 0 0 0 0 0 0. Now we have 0 to 2. If we know that from 0 we can increase, and 3 we can decrease -1. From 3 to 5, from 3 we can increase, and 5 so 6 we can decrease 1. From 4 to 6, 4 we can increase 1, and 6 7 we can decrease 1. From 6 to 8, 6 we can increase 1. From 8 we can decrease 1. Sorry, 8 9 we can decrease 1. So this is what we created by this intervals. Now we'll do the pre-sum of this, and we'll try to figure out how many values were increased at what place. So 1 plus 0 will be 1 over here. This was 0 again, so it will be 1. This is 1 again, so it will be 2. It will go 2. This is 0, so 2 minus 1, it will go back to 1 1, and minus 1 it will go back to 0 and 0. So I can see that these are the values that are increasing. If we try to find like we are at range, suppose at 1, at 0, we can say that only there is one interval, overlapping interval possible over here. So for 1 we may have 1, and the operations that we can do is more than the value over here. So obviously we can create 1, which is nothing but 1 only. So 1 is possible. This is also same, this is also same. Here we have 4. So the number of applied operations can be is 2, and we also have 2, so it's fine. We can say that 2 can be one of our possible answer. For 5 also the number of operations is 2. We have 5, so it's fine, we can again say 2. For 6 we see that the number of operations that we can do is 2. So what this 6 is actually saying, that 4 and 5, we can convert this 4 to 6, and we can also convert this 5 to 6. कैमरा में घुस गया है। ब्रो कैमरा में कहाँ घुस गया हूँ? अजीब हो यार, रुको लेट मी चेक। अब ठीक है, नाउ इज इट फाइन? पूरा हेयर सेट करके बैठे हो आज क्या? माय हेयर इज ऑलवेज सेट ब्रो, को सेट करने का ज़रूरत नहीं पड़ता। फोकस ऑन क्वेश्चन ब्रो। और जिसके पास हेयर होता है वो सेट करता है ना पॉइंट। Now there's one thing. If number of operation was 1, I can say if I am at 4, I see that I can do only one operation, but still my answer will be 2. Why? Because I already have 4 in my frequency map. I already have 4 and I'm converting this 5 to, I can convert this 5 to 4. So answer will be 2. So we need to check in my map if that value is already there, we can reduce 1. Seeing and actual being is a different thing. So let's have this kurkure solid masti. ये खा रहा। Okay, so this frequency map I'm directly adding my nums of 5 plus plus. ब्रो पच जाएगा ब्रो तुम्हारे जैसा नहीं है, तुम्हारा नहीं पचेगा ब्रो। And Okay, I can have like max and min range from where we can kind of start the operations. Or we may like it's always better to use those points, and instead of going for max and min range. So I have this frequency map. Just I know you have a curse, and तू जो भी खाएगा मेरे बिना नहीं बचेगा. Nums of I minus k plus range nums of I plus k plus and range of nums of I plus is equals to. So this is my frequency map. Now now while my range is not equals to what I'm doing is I need to do pre-sum of previous element. Oh, okay. It should be minus minus, and that to k plus 1. So and there will be a pre-sum. Now pre-sum plus is equals to it of second. That will create a pre-sum value, and will be going with I added the pre-sum. Okay. Why I added? If the value is already there in the map, Now, number of operations left. My answer would be kind of maximum of answer. Now I need to check if frequency map of IT of first is not equals to frequency map dot end. What actually we were thinking over here. We had only one operations. If this value was present in my map, array, then what will happen is I'll reduce my value once, and now whatever left will be stored minimum of val comma min operations and maximum of val. Return answer. Let's see. Frequency map dot find ID first. Sorry. Value is equals to value plus sorry case. Second test case will fail if we have here 18. Should be 3 and my answer is coming out to be. So how much frequency do I have? Frequency map of I take off first. That many frequency we have. and that many frequency will be reduced. I'm sorry. Okay. So what is the time complexity for this? Because we are using map, this will be n log n, and a value. Let's submit and see if this is working or not. Okay. White came out to be 1. Eight 88 minus 27, what's that number? 61 plus 27 will give me 115. This will be like plus 27 minus 27, so plus 27 will be 80, and minus 27 will be 50, 30. साढ़े 10. So we have 61 as 1, 26 as 1. Okay. 26 as 1, 53 as 0, then 61 as 1, then 80 as minus 1, then 115 as minus sorry 81 as minus 1, oh, 115 as 0, and 116 as minus 1. Right, this is what our range is. So we have this 26. So pre sum is something which will start from like 1. Okay, value is if 26 is there in my map, in my frequency map. No, it is not there. So like there is something mistake, silly mistake that I'm doing over here. This time third passed and second failed. Okay, let me check what is the mistake that I am doing. Is something related to these three things. Now pre-sum is 1. I know that pre-sum is 1, that is fine. And 26 is not present. So max like val is like 0 over here, which should not be the case. Val should be like pre-sum, and I'll have to check this minimum of val comma. Why this is like but why I have this pre-sum as 1. I set this value as pre-sum, and if 26 was there in my map, it's not there. How many operations are allowed to me? 2 operations are allowed to me, but my val pre-sum, my val is 1 only, so answer will be updated with 1. Next time for 53, again it's 1. I'll check this 53 is present or not. Yes, it is present. So what I will do, I'll update it with whatever value this had is like 0, then value plus pre-sum minus 0, that is 1. So val will be updated with 1 again. Now for 61, this will be updated to do 2. Now we have 61 over here. Pre-val is 61. Frequency map IT first. Do we have 61 in my map? No. So this time my answer will be like val is 2, this 2, this will give 2. Answer will be updated with 2. Okay. For second test case, okay, now let's check for the second test case. We have k as 5. So 5 minus 5 is 0. 0 plus 1, 10 पे minus 1. 11 minus 5. 6 पे plus 1. 11 plus 5. 16 पे minus 1. Sorry, 17 पे minus 1. This will be 11 पे minus 1. 20 minus 5, that is 15 पे plus 1, and 26 पे minus 1. 15 पे plus 2, and here minus 2. Okay. We have 11 पे negative 1 है, 0 add, we added 0. For 20 we added 0. Okay. So we have like pre-sum as 1. Val is equals to like pre-sum. Is like 0 present in my map? No, it is not present. So it will be like, what is the number of operations that I can do? 1. Pre value is also with 1. 1 1 1. So answer is updated with 1. For 5, 0 again is present. Yes, present. So frequency map IT of first. How many frequencies of 5 are there? There is only one frequency. So val will be updated with like 1. How many more to add? So like 0 5 6. It's 1 1 2. So we have 5 already. So total pre-sum would be, okay, give me a minute, I'll be back in a minute. I'm back. For 5 also it will be 1. How many frequency we have? 1. These many are left. Okay. For 6 we'll have 2 as frequency. Do we have 6 in our map? No. So the operation, like minimum operations of value, will give me like 1 only. This is something now it's coming out to be 3. How come? And it will be 1, and then 15 it will be 3. For 15 it is 3, right? For 17 it will be 2. For 20 it will be 2. Frequency map val will be okay. Val plus prism, which is 2 minus 2 is 0, and nums operation is 1. So out of these, which is minimum? It's 0. 0 will be added, so it should be like 2 only. Why it came out to be like 3? At what value of val is coming out to be And if I do mean operations based on this, so for 15 it's 3, for 15 it will be 3, these three values, and is 15 present in my map? Try and submit this. Okay. uh, and what if I comment this line and these lines, let it be. Okay, so this is working. Let's try it here also. What is the thing that is changed? Is like the value. So for this, maybe we can convert this integer to long. mm, yes, let's convert this to long. Rest, I think, rest everything will remain like as it is. uh, Great. So okay, great. We were able to like solve both maximum frequency of an element after performing operations 2 as well as 1. It is not like that difficult, I would say. but yeah, it was little tricky. The only thing we should remember here is whenever we are in range, we need, whenever we are in, anyway, we don't need this. We can like, okay, so fine, great. We were able to solve these two questions using line sweep algorithm. So this is actually a very good question of line sweep algorithm. I would paste. Okay, so this was a good line sweep algorithm based question, and this is nice. Let's try. I'm not sure if I'll try this one. Let me see. No. Okay, so okay, I tried this. Some of good subsequences. I actually gave this as a virtual contest, and luckily I was not able to solve the third question. I was able to solve the second question. It is not that, like, I would say, difficult. Okay, yeah. So this is not that difficult question. I would say it was like just a pre some question kind of. I tried this question. Actually, I was confused with. I did not see this specifically subsequence part. I was trying it with a sliding window approach, simple sliding window approach with a sub array, and which took me for good. So I got a little confused with the subsequence and sub array part. If this would have been a sub array, and then this solution would have worked easily. But if because it is not a sub array, it's a subsequence, then we need to do something. Okay, let's think over it once more, how we can approach it, and then we'll try to see if we'll be not be able to find any solution for this. So we are given an integer array nums. Okay, a good subsequence is defined as a subsequence of nums where the absolute difference between any two consecutive element in the subsequence is exactly 1. Okay, return the sum of all possible good subsequence of nums. Since the answer may be very large, return it 10 to the power 9 modulo 10 to the power 9 plus 7 modulo. Note that a subsequence of size 1 is considered good by definition. Okay, so one size of subsequence is always like going to be a good subsequence. So we have this 1 to 1. This as a subsequence. We have a subsequence as 3, 4 and 5. This is another subsequence. And there is a subsequence of 3 and 4 here, and skipping it. So this is what this test case which took me. Okay. Okay, now I need to find a subsequence kind of thing. So 3 to 1 2 1 3 4 5 3 8 4. Return the sum of all possible good subsequences of nums. Okay, what can we do over here? And we do not have to find the count here, we have to find the sum here. So if we have 1 to 1, all the possible subsequence sum, if we have like 1, it's fine. If we add 2 over here, so total like pre-sum, currently my pre-sum starts from 0 to 1, and we have 2 over here. Now we need we will be having what if ending with 2, we'll be having 3 and 2, the plus 3 plus 1, that is 4 will be added over here. So total will be like 5, plus we have 1 again, right? So for this one, so 2 plus 1, that is 3 plus 1 4, it will be like plus 4 plus 3 plus 1. One, बारह, तेरह. It should not be 13, it should be 14. 3 plus 2, sorry, this will be 5, this will be 6, and this will be 14. So now what is happening is we have 1 2 like so till here there are total of 6, that means 1 2 and 2 included. Now in both of them I have to add 1 here and extra 1 here. So total in 6, how many count were there? Like 2 were total count. So 2 times 1 will be added in this, which will be like 6. Six plus 2 into 1, 3 into 1, that is 3. What we were doing, my left pointer is here, my right pointer is here. Current sum is something 6 over here till here, right? Now 1 is added to it. R minus L, that is 3. 0 1 2, 2 minus plus 1, that is 3. 3 into so like 6 plus and this will be like 15, not 14. What is something that I'm missing? total sum was 0, 0 plus L minus R plus 1, that is 1 into 1, that is 1. So sum 1 added, and my R is here, so sum plus, so result is like 1. Sum is like 2 into 2, that is 4, plus 1, that is 5. So plus 5 added, that is 6. Oh, sorry, so it's 5, right? 5 plus 3 into 1, 8 plus 8 added, which is 14, and correct. So here what we are having, like always uh, we need to know the count. So it's like pick and don't pick solution. If I pick this element, the length is like 10 to the power 5, right? Hmm. If I'm picking this element, the count will increase 1, and when I'm picking this element, I can pick this element, I'll go, when I go beyond, I'll come back here to this position. I'll keep my sum as a count as 3. We have 3 as count here, so 3 uh, into 1, so 3 will be added, and I'll return back 3 over here. Here what will happen, 2 is the count, so 2 into 2, 4 will be added, and I'll return the count. Here 1 into 1 plus 1 will be added, so only 8. Some 3 is added in same sense of what? This, and this. So these are the three numbers which are added. And I'll fall back to this position. Whatever value this will attain, I don't know this value. I know that 2 times 4 will be added plus this 3, that is total in total 7. Will be okay. Let me see. 3 added to my sum. Now 2 to 4, 5, 6, 7 plus more 7 added to my sum. When I fall back, I have 1. No, while recursing back, how? I cannot like do n square operation, obviously. Okay, let's do like one by one, maybe, and then we can think of something. Let's erase everything. I know one thing, that this will be like pick and non-pick solution. So 3, 8 and 4, if we have this 3, 8 and 4 as my array, so I know I if I pick this like 0, 1, 2, I know 3, I have 3, I have 4, and then I cannot pick this. I'll not pick this, I'll go here. I can pick this because previous element was 3. So I need to track down the previous element. Now I have this 3 and 4 as my kind of array created, a subsequence created. Now this 3 and 4 will have something, my answer. 4 into 2, 8. 8 plus 11. Fourteen. 3 and 4. For 3 and 4, it's like 14, right? 3 is only alone, and this and this. 5, 6, 7 plus 7 plus 4. 3, 10, 4, 14. This is 14, this is 14. So I know will give me like 14. I've create all the subsequences possible with a difference of 1. I created all the subsequences possible, right? Now it's time for finding the answers. So like when I fall back to this position, I can like do from back also same thing, 4 as my sum, and then when I came to here, 3 into 2, so like 4 plus 6, that is 10, so plus 10, that is 14 is my answer. So what happened actually, I may declare this as global, and I'll keep adding to it. So what are the things that we need to remember? I need to like pass how many count we have from previous, that many times this will be multiplied. So something like count and there will be a sum being tracked down, and there will be an idx index. There are 3 things, and this count can range up to 10 to the power 5. This sum can also range up to a lot more than this. IDX can range up to 10 to the power 5. So this like memoizing this is like insane. Won't be possible. I cannot create. Now how? The question is like how? Uh, do we really need something? Like this count will be like from falling back. I only track count. How many count are there? How many count are there? I don't need this I can only work with IDX. Can I? So we have this global sum. We got a count of 0 from back. Now this 4 like For this position, will be having, for this, if I get a 0 from back, uh, it'll say that this there was nothing after this, so sum will be added like 4 for now. When I went back here, the count is 2. So whatever sum had in no we are only handling this as a subsequence, right? And then we are saying the sum, but this global sum will be something. Thus this sum is being tracked down, right? 4 plus 6, that is like 10. So global sum had 4 plus 10, that is 14. So we need to like track down count and sum. Maybe let's try this once. I was doing like same thing. Let's make this as sum and this is count. So sum will be like 0 and maybe I'll send count as 1. Like will need to have this previous index so that I can get to know which next index to call. If previous index is, so I'll do anything, it's fine. Else previous index minus current index should be equals to 1. If it is equals to 1, then I can do the pick part, and then I don't want to pick this. It's fine again. Now when I'm falling back, now suppose I fall back. For now, let's call this the easiest one. So global sum is 0. Okay. Let me uncomment this. So when I fell back here, so this There's something I'm missing over here. Okay. I need to know, is there any recursive solution over here? Oh, time complexity n square. Ah, we cannot upvote. There is no upvote thing now. Or can we? Okay, let me see the what exactly he did. Consider index I. The next index would be containing nums of I plus 1 or nums of I minus 1 as value. Correct. I need to understand this. I can't skip these types of things. They are like very good. Okay, what more I can think of? There's something that I got is uh, we had this current index like 384. If I am at this index, I know there will be like two values for 3, that is either 2 or either 4. If they are present, possible I can use it as a subsequence. And subsequence like cannot, it's like 3 2 and 2 3 4. 3 2 4 is also one of the answer. 2 3 4 is also one of the answer. So in any of the case, if you consider 2 3 4, then 3 2, no, 3, I can go to 2, so I can go from 2 to 3 then 4, not from 3 to 2 and 4. This is not a subsequence, right? 2 to 3 and 4, always increasing, like might be decreasing also. So if I have something like 2 over 2 3 2 3 2 2, 2 3 2 and 2 3 2, so 3 2 2 will be like 3 2 1 possible, which will have a some like 3 plus 2 plus 2 is 1 possible. 3 3 2 is plus 5, so 12 is total answer. If I see this, maybe I'll try to reset it and return for now, and I need to know this test case 3 2 2. So 17 is what it is saying. So we had like 3 2 and then 2 3 2, so we'll be having 2 3 and 2 also. So 2 3, why it is 17? What is the possible subsequences that we can create? I can create 2, I can create 3, I can create 2. So 2 is like it should be distinct, is it so? Two three two 2 3, so like 3 and 2 is also 1, 2 and 3 is also 1, 2 3 2 is also 1, right? So 3 4 5 6 7, 5 plus 5 plus 7, thus. So this is like, this is already there. So 2 and 3, that is 5, and 3 2 and 2 3 are same. That's what he's saying. So it'll be like 5 again, and this is 7. So total of 17. No, this should not be this. Okay, let me add 3 2 2 2 3 2. Answers will change, I guess. This time it's 24. Earlier it was 17 only. Why 17? Because in 3 2 2, in this case never comes. So we have 3 2. This case will also not come. Because 3 2 and 3 2. Plus 3 2 again. This will be 7 plus 5 plus 5. So that is like 17 total in total. Okay, give me a minute. POTD किया. POTD मतलब Hi Shivam. What is POTD? Okay. This should be something easier than this. How they solved it? Easy to understand. Okay. So we have this as C and subsum as two arrays, auto input nums. Okay, we have this input as separate. What is doing is iterating over each of the nums of value, current C and current. So, okay, this is current count and current sum. Current sum is nothing but this value, and this is my current count. If num is greater than 0, if num is lesser than this, if num is greater than 0, if num is lesser than this. What? Okay, fine. If like, let's take this as an example. 3, 8 and 4. If num is greater than 0, correct, 3 is greater than 0. Current of C, current count is equals to current count plus C of num minus 1 modulo mod. So current C. Current C is equals to current C plus count of num minus 1. Num minus 1 में का जितना count means I'm finding 2. Whatever is there, add it and see. If num is lesser than 10 to the power 5, I'm checking plus 1. If it is there in my map, then update C. This is for count, these two are for count, and these two are for sum. If num is greater than 0, current sum is equals to current sum plus sub sum of num minus 1 plus long count, previous count into this. Why it is like num is lesser than 10 to the power 5? Isn't it this current sum should be added here? I'm updating current sum in both. Result is equals to result plus current sum. Okay, is adding this current sum only, so whatever updated here, that is added to the next one. Okay, I need to know the exact logic. How is it here? Again, this is like, okay, I need to know. 384 and 2. So we have this count map, we have this sub sum map. So we have this first element as 3. We have current C and current sum, right? So we don't have anything in my current C and current sum, and we have num for 3. We have current C, current sum as 1 1, and num is 3. If num is greater than this will not work, this will not work. If num was greater than, so current sum is 3, sorry. So current sum 3 plus subsum of num minus 1, which will give me nothing, 0. This is 3 plus 0 plus long of count of nums minus 1, which is 0 into 3, which will give me like current sum as 3, updated only 3. And same here, this will be 0, this will be 3. So result is equals to result plus current sum. So result is my updated with 3. Count of num is equals to count of num plus current count. Whatever current count we have, that will be added. So count of num is like 3, corresponding to 3 will have 1. And subsum is equals to subsum of num plus current sum. The subsum of num 3 so this is nothing like a dynamic programming. This is like hash map. Okay, let me check some of good subsequences. I'll have to understand this. Okay. Let's Okay. It's like I need to find the count. So if I'm at this position, I need to know, have I seen 3? Uh, like this value minus 1 previously, or this value plus 1 previously. Mm, mm, if I have seen how many count was there, add 1 to this. And whatever had, it's like 4 minus 3, 4 minus 1, that is 3, 4 plus 1, that is 5. All those subsequences will end up here. So whatever subsequent sums are there will add up over here. That's the count. That is the way of count. And simply I know, if I know the count, I can simply do the thing that I was doing previously. Instead of like doing a DP classic knapsack, I could do okay. Now I know the like count, and for this, what is the sum? I know that. I know the count. I'll just, and this is my sum, and that will be added. And same again for plus 1. Whatever sum we have, whatever count we have, multiplied by this. This is some, okay. Okay, so maybe I'll take okay. This is my subsequence count. This is my subsequence sum. So I want to have the how many counts are there and what is the sum at that position, right? And that with this formula will do the job, because this formula is deduced, which I deduced. Okay, fine. So let's see auto num from nums. We'll take each and every value from nums. Now we need to find its -1 is present or not, and +1 is present or not. So if like num -1 is greater than equals to 0 and subsequence count will be what will be subsequence count? Count dot find num -1 is not equals to subsequence count dot end. Means if it is there, I'm checking whether this number -1 value is there, then that means and I do have to, I'll keep my resultant okay, right, okay. So subsequence count, if num -1 is there in my map, what I will do is I will take that count. So maybe I'll pick that subsequence count from my map, then I'll take I took that count from my map, that is the count. Now I need to know sum also. So subsequence sum of num -1. Now this is my current sum and this is my count. So my resultant will be so this I have a result. So maybe long sum will be nothing but count current sum plus we have the count multiplied by current value, that is my sum, and that will be added in my result. So I can directly make it as result as current sum plus this modulo mod and total also modulo mod. And after this I need to update my current sum. Okay, let me take it as sum and result is equals to result plus sum. Modulo mod. Now my sub sequence count of this num will be subsequence count of like num minus 1 . So maybe I can do this outside. I should not be doing this inside. And subsequence sum of this number is subsequence sum of num okay. So maybe I'll keep like count outside this sum also outside I need to update uh, so whatever we had in num minus 1 plus 1 will be added over here, and now whatever we had in the previous sum plus this sum is like previous sum plus this, so this sum will be directly updated because sum is like Now same thing I'll have to do. If num is like lesser than 1 and 2 3 4 5 and plus 1 is there, so everywhere it will be plus 1 plus 1. Modulo mod, and this time it will be like plus 1 plus. At last I'll return some. Okay. If num minus 1 is like greater than equals to 0 and subsequence maybe I'll not do this even that will not change my answer. Okay. So we have initially 1. So count is a subsequence of count of num minus 1, that is like whatever count we have previously of num minus 1. Current sum will also be num minus 1. Sum will be to count into num. So current sum is 0, count is like 1 into 1. So result will be added with like 1. and now my map will be sub. This is my like count map, and this is my sum map. Count map will be 1 corresponding to 0 plus 1, that is 1. Sum will be 1 corresponding to 1. Total sum is 1. Yes, it is. Is it present? No. So sum again, count will be like 1. I need to have that condition. Okay, there's something I'm missing. Extra is being added. If it is not there, I'll just simply go here corresponding to 1 1. I made nothing, and sum is like 1, so 1 will be added. For 1 to 1 we are finding. Plus 1 is also not there. Subsequent count of num. It's like this is being done twice. It didn't go here, it went here. So subsequent count of num is like 1 plus 1. So it is counting it this as 2. Everything is being counted as 2. Which I don't want. And if I add this both in if condition, we'll get to go nowhere. Why am I coding such bad? Why I'm doing so bad coding for this question? Sure. If I do this, it'll be 0. I knew that it'll be 0. Nothing is going in my map. Else if it didn't go anywhere, I'll simply do what, and this is num. Okay, now there is something, a few cases that I am missing. So we have this, we went to 2. So we reached over here. We went to 1. It might be possible to do, there are both ways. This is also there, this is also there. If nothing worked, I would say that why am I doing such a bad coding? Why am bad at this? Why you use these wrong variable names? Don't use this. We have this as a count and sum. Fine, we have this result. I have this, correct. I'm iterating current count and current sum is like 1 and nums of I. Is like count and sum is 1 and nums of I. It's fine. This is my finding of first, finding 2, second, which is like nums of I minus 1, nums of I plus 1. So current count will be like total of how many counts we have from this. I added in my current count. This will be added with 5 of subsequences. Current sum will be like current sum into sum of find 1 plus count of find 1 into nums of I, which I did. Count of find 1 into nums of I. count of nums of I is equal to count of nums of I, whatever value we have over there, plus current count modulo m. This is where I need to understand why we added current sum with, and current sum is like nums of I. We are taking this as nums of I. Should be like 0, start with 0. Whatever we have in find 1, that into count into this num. Okay. Count is giving me previous count. One more is left, which is the current value only. So that is what he added over here. Now on that value, this is being added, which is find 2. That is why he used nums I over here, and result is added with current sum. Whatever we have, and and why I am doing like so long things. I shouldn't be doing this. This much confusion is like so bad. We have current count and current sum. I should not get confused over here. What exactly we need to do is very simple. It's like I'm kind of overthinking a lot on this. Find 1 is nothing but num minus 1. Find 2 is nothing but num plus 1. And why I did num is like the real logic. If I do not do, what I'll have to do is have this find 1 and find 2, I'm not able to understand one thing. If I have this count I need to know like there are a total of 7 places where I need plus 1 extra place for this. I'm already adding 1 with find 1 and find 2. So find 1 like gave me 2. There were 2 subsequences ending at num -1 and 3 subsequences ending with -2. Num plus 1 extra I've already added in my current count. Then why in current sum we are doing that? Oh, because we are not multiplying with current count. We could have done this in a single line. This will be current sum is equals to num. First time we are adding a num extra plus subsequent sum of find 1 plus subsequent count of find 1 into num. Subsequence of find 2 find 2. Subsequence sum of current num is equals to current sum and subsequent sum of current count will be subsequent sum of current count plus find 2 ouch. Oh, sorry, current count, not num. I have this find 1 and find 2. This num will be added once because we are having one extra. Subsequent sum of find 1 into subsequence count of find 1 into num, subsequence count of find 2 into num, subsequent sum of find 2, and current sum result is equal to result plus current sum. Kind of maybe. Wow, I'm adding in my current subsequent sum. Now what is the problem? Not using current. This is my find 1, this is my find 2. Plus find 1 plus count of find 1 into num same current sub plus result is equal to result plus current sum. That is what I'm doing. Count of num sub I is equal to count of num sub I plus current count. Current count is nothing. Whatever we had previous to, it'll be added one more now to this, because this is one more count that we are adding. Can I take this? लॉन्ग लॉन्ग में नहीं कर सकते. Don't do this. Oh, I think it's because of the count. Like these are really uh, good questions. Very, very, very good questions. This is like these things will open our mind. I was very much stuck to like DP of picking and not picking part. I never like as in my mind was not even going to this solution, and can be solved. Like these subsequences can be solved using map also. Insane. These are like really good logical thinking. Okay. Okay. Fine. I'll take a break. No, I'm feeling hungry. Very hungry. So I'll be back in maybe in 30 to 40 minutes. 40 minutes, okay. I'll be back in 40 minutes, and don't go anywhere, and then we'll start to solve more questions. Maybe even I'll go with this count k irreducible numbers less than k. These nowadays question levels are really amazing, and it's good. It's really good. These are like, you need to always be mindful in solving these questions. If you're not mindful, you won't be able to solve any of the question, right? Cool. So I'll be back after some time. See you. Bye bye. Okay, I'm back. Let's go. Count k reducible number lesser than n. Where were we? Okay, so let's directly jump to the question and let's see if we are able to solve it or not. So we are given a binary string s representing a number n. Okay, in its binary form. Okay, this is a binary form of a number. You're also given an integer k. Okay, we are given an integer k. Alex, good luck. Hey, thank you, Alex. You also can try this question if you haven't. You're also given an integer k. Okay, that's fine. An integer x is called k reducible if performing the following operation at most k times or reduces it to 1. Okay, I need to perform some kind of operation k times to reduce the number to 1. Okay, replace, what the operation is, replace x with the count of set bits in its binary representation. An integer x is called k reducible if performing the following operation at most k times, reduce it to 1. Replace x, okay, what is x? With the count of set bits in its binary representation. Okay, for example, the binary representation of 6 is 110. Applying the operation once reduces it to 2. Since 110 has 2 set bits, applying the operation again to 2 reduces it to 1, has 1 set bit. Return an integer denoting the number of positive integer lesser than n that are k reducible. So it's saying return an integer denoting the number of positive integer less than n that are k reducible. Okay, given string is 111, fine. Number is 7. The 1 reducible integers less than n are 1, 2 and 4. Okay, we have 1, 2 and 4. So set bit for 4 is kind of obviously 110. So a kind of built-in pop count will give me the count of set bits. So it's 1. For 2 it's also sorry, it's 1, and for n 1, it's 1. Now string length is 800. Okay, kind of the difficult part over here, I would not say difficult, or I would say the complex part over here is somehow I need to know, are you looking for a job? uh, might be, might not be, like kind of I'm in a job, I'm kind of preparing for anything that comes up. Exactly, that is what I'm doing. Okay, so if I see 100, I have this integer 8. There are 8 numbers and k reducible. Okay, I at most k times reduces it to 1. Okay, I need to apply k. So what is k? range of k? K is only 5, so that means string length is exactly 800. I cannot iterate from 1 to that many numbers, and for each number, what's the brute force here? So the brute force will be something like start from 1 and go till whatever s length string says, like the maximum number that s length can attain. So going till 800 is something, is something 2 to the power 800 minus 1. So if I see this, I need to go from 1 to 2 to the power 800 minus 1, and for every number I need to check whether it is k reducible or not. This is some kind of a brute force. uh, uh, okay, thank you so very much, Alex. So we are not allowed to ask these hard questions during interviews. Medium is enough. Yeah. Actually, it's just I just want to improve my skills. That's why I do. I love to do coding. So that's the reason I do. So if you want, you can like ping your LinkedIn ID or something in the chat. I'll connect with you. It's really great that you are coming up and saying this. Thank you very much. Okay. So where was I? There are no positive integers lesser than 1. Obviously, I need to run every number over here. Can you paste your LinkedIn link here, Alex, if possible? Or if you want mine, I can also do that. So the answer is also it's saying. So there must be some kind of trick involved over here where I should not be iterating over each number. Like, is it possible for every number to become k reducible? That's the first thing that comes in. Is it possible for 10 to be k reducible to what? So every number will have a count, right? So if I suppose I have a number something like this, so what's the binary count? 1 2 3 4 5 6 7 8 9. I have 9. Now 9 binary representation is something 8 plus 1. So 1 2 4 8. Now it's 2, and 2's binary representation. So okay. So is it possible for every number to fall down to 1 in at maximum of k operations. So k is something 5. So going to 1 in 5 operation, I need to know, like, is there any number which will not go to k? So I have 7, 1 2 4, so okay, so 3 is something we are saying that it will not be reducible. It will be reducible if k is like k is 5. I would say all the numbers that are like possible, uh, for now I'm assuming if k is 5, because the count is reducing very drastically. I'm not sure if it is reducing in logarithmic time or even faster than that, but the counts of binary numbers are reducing very drastically. Okay. Okay. So in this case, what would be our approach? What would be our approach? Since since the numbers are really huge, I cannot iterate over each of the numbers. I need to somehow find a way to reduce it, to deduce like how is it possible. Depending on k, if k if k is 1, what is the maximum numbers possible? All the numbers who has only one binary count, set bit is 1. So if k is 1, only those numbers will be added whose binary set bit is 1. Binary count is 1. This is something for k is 1. For k, if 2, now I have 2 to the power 800. Now all the set bits are set. Suppose all the bits are set. 2 to the power 800, that means a maximum of 800 bits will be set. Okay, that's the maximum that we are taking. Let's deduce this. So 800 bits are set. Now 800 binary representation will be what? I need to know kind of binary representation of 800. For 800, I know there is 256 and 500. Fine. So the binary representation of 800 is 1 2 3. Okay. For 800, it's 3. No, 3 as 2 and 2 as 1. So 1 2 3 4. So at max k is like 5. If k is 5, I can do all the numbers which are lesser than that. So that is what I'm supposed, because the range is this, and if I deduce that, so 1 2 3 4, in 4 steps I'm able to reach to 1. So even k is 5, I would say for if we have k as 5, return the number -1, whatever the number we will be having -1, and I need to kind of like modulo it. 10 to the power 9 plus 7, because it will not be possible. Okay, that's I'm sorry. Okay, that is totally fine. Now I need to know uh, if a kind of um, I'm judging if what if we have 1 over here and rest of the numbers are 0. We know it's so if the number is 3, it'll take uh, 2, k is equals to 2 to reduce it. If number is like 7, so if we have number as 7, it'll boil down to 3 and then 2 and then 1, right? This has 3 set bits, so 3 steps means k, it took k as 3. Now first and foremost thing, k will be 1 at least, so all the set bits will be in our answer. So this will be in our answer 1, 2 will be in our answer because this is also a single set bit, and this as a single set bit, every 4 will also be in our answer. We are pretty much sure about this, that all the set bits will be in our answer. For here also, this 1 2 4 8 will be in our answer, but the number should be like lesser than 8, so we cannot take 8 exactly until and unless we have another set bit. So if we have a set bit before the last one, I just need to check if we have another set bit. 8 can also be one of the possible answer. Okay, that is just an edge condition that I would have to handle. But if not, now I need to have, if there are 2 set bits, if there are 3 set bits, if there are 4 set bits, if there are like 5 set bits, now how it will affect our answer pattern. That is what I need to know. If we have 0 over here, if we have one more set bit, or maybe 0, 1 1 1 1 1, let's suppose, how will it depend? This is 3, it'll turn out to be 2, it turn out in 3 steps, it will be fine. So this is 4 is like in a power of 2. Okay, 1 2 3 4 5. So we have like, how many set bits are there till here? 5. So for 5, it'll like boil down to for 5 from 5. This is a odd number. Like if we get a even number, is it like always going to be directly it'll jump to something? No, 10. If we suppose we have 10, we have 8 and then 2, 1 2 4 8, so this will be 8. So we have 1 2 4 8, so this is 10 something. This will be reduced down to 2 and then 1, right? 2 set bit 10 has, and it will directly jump to 1 if I change this. Okay. Even numbers, what is the maximum even number? There must be some specific way to say something like this, because I don't see any kind of like a DP pattern over here, or something like that that would help me in solving. It kind of looks to me like a math problem and not really a DP one, or even any other problem than this. Um, I need to deduce something. So if we have 5, 1, 2, 3, 4, 5 asset bits, what can be, so like 5 will maybe 1, 2, 4, 2 count, and then it'll turn out to be 1. 7 was also 3, 2, 1. Hmm. Yes, correct. The original number will be reduced to 800 after first operation. So the maximum that I need to go is like 800. So from like 1 to 800 we can um, even iterate over that number, and then we try to figure out things. Hmm. That is also like one way. Like, is it like always going to be the case? Like making it power will like give me is not possible. So the basic was like 2 to the power 1. The number is like 2 to the power 0, that is 1, which is obviously 1. At this position, how many bits are set previously? Only 1. So that makes me it to be like 2 set bits are there. Here I know how many set bits are there in previous. So like 2 set bits are there. Just first thought is DP on bit mark, since 800 is only about 2 to the power 9. Yeah. Uh, just first thought is DP on bit masking, since 800 is only about 2 to the power 9. Correct. 800 is okay. DP, I I need to like kind of I know the situation, that whether it is possible or not. So maybe I'll think in this way something. I'll store kind of somewhere in my result, and I have this result. So for few stuffs I already know, like for 1, 2 and 3, if they are set, what should be the output, and for rest we can like try DP. It may not work. Yeah. I'm too doing the same stuff, throwing out ideas, so it might be possible that it may work, it may not work. I just got something which might be uh, possible. Like one you know, for 1, if this is set, how many mm, steps it will take for 1 to reduce to 1, and that's k is equals 0. For 2 to reduce, now this this bit is set. How many bits do we have behind this is individual, that will be uh, counted in my answer. Now how many bits are set behind this? So we need all possible. It might be I should not directly go. Okay, no, this might fail because I'm directly iterating over this 1 1 1. This is saying something. We have 7. In between we have uh, we counted 1, we counted 2, but we didn't counted 3. Right, for 3, no, we did count 3. We did count 4, but we didn't count. We will not be able to count 5 because for 5 it is 101. 4 and 1. Somehow we need to like store somewhere. So this can be like a storage point where I will be storing the values. How many values do we have? Yeah, that I thought of, like for below 800 I can directly iterate over numbers from 1 to 800, and only we have to calculate till 5. So like 5 into 800, that will be very much possible. But I'm thinking of like all the possibility. Will every possibility be covered over here? Because I know if like numbers from 1 to 800 will not produce that much answer, that it will be like 10 to the power 9 plus 7. It will go beyond something like this. It is saying to modulo it with 10 to the power 9 plus 7. That means it has something. That is what I'm currently thinking. Like the maximum is from 1 to 800 will be answer will be of 800. The maximum answer that it can go is 800, but only 800 is not the correct answer. Okay. It's something we are at this position. We know how many bits are there previously. 2 bits are there, including this will be 3. Now for 3 to boil down to 1, how many steps do we require? That is somewhere that needs to be stored somewhere. No, but if I like look at this step, till here we are fine. When I jump to this, there are numbers that I am missing over here. The numbers is like 5 we are missing. We are missing these 2 numbers as well. 6 we are missing. We directly went, we missed, we took 7, 1 2 and 7. We missed 3 3, 4 and 5. Even if we took 3 also, so 4 and 5 we missed. There will be lots of numbers that will be missed in between if we directly jump bitwise bit. Yeah, we can calculate it, but I don't think that this is going to give me the correct answer. Like, we know there are 800 bits set, but there are numbers which are missing in between. These numbers are also k reducible. Like, from 1 to 800 there will be lots of numbers that will be missing. uh, like, calculating from 1 to 800, 1 2 3 4 5, so that will include 4 and 5, but the maximum answer here in this case, if there are total of 800 also, it will give me a maximum of 800, because one suppose one is reducible, k reducible, so it's fine, that will be counted till 800. Everyone is k reducible if k is 5, so the maximum is 800 only, but that is not going to give me the correct answer, because it may be very large. The number is still very large, 2 to the power 800. There are more numbers than 800 also. Or are we missing something? Is it something that I am not looking at? Maybe like DP, pick and not pick. If we go kind of pick and not pick situation in this DP, what will happen? Yes, we can try DP of pick and not pick. That'll like possibly do all the combination stuff. I'll pick this, I'll not pick this. No, I know I have picked a lot of numbers. uh, what is the count of it? Binary count. Okay, the maximum it can go is like 800. So 800 ones are there. Everyone has a possibility of being picked and not picked. Something pick and not pick. So if we are picking a current number, then it will be like in my count. If we are not picking the current number, it's not in my count. So there will be something which will say how many counts are there, how many counts are not there. Okay, based on count, will I be able to check whether it is k reducible or not? So for every combination, we'll check whether it is k reducible or not. Right, okay, yes. Right, so if we have a arbitrary number n with k bits set, okay, with k bits set, okay, it will be reduced to k, correct? In one step directly it will be reduced to k. How many numbers are there of length n that have k bits set? They will all be reduced to k. Yeah, correct. So like if I'm saying 2, 2 is the set bit. Like if we take this as an example, we have 3 set bits. So in total, in next step it will reduce down to k 3, right? So how many possibilities are there? So it might be like a combination in total of how okay in total we can say we have 1 2 3 4 5 5c3. How many combinations are there of 3? Okay, so we can do like 5. We can start from 5c1. How many combinations are there of 1 possible in 5? So it will be 5. 5c2. How many combinations are there of picking up 2 from 5? How many 5c3? How many combinations are there from 5 to pick 3? Right. Okay, so there are like 3 combinations. How many combinations are there to pick 4? And how many combinations are there to pick 5? And this maximum can go till 800. And for 800 I need to find how many combinations are there. How many combinations are there? So it's like for every number I need to find how many combinations is possible. And for every combination, like I can kind of like so first thing, if we are picking 2, like from 5 we pick two combinations. Is 2 like even possible in reduce which will reduce, like if I have 2 set bits, is it possible to reduce it to 1 with k operations? That I'll check first. If it is possible, I'll add all the combinations in my sum answer. Similarly, I'll check for 3. If it is possible for this to reduce to 1 with k within k operations, then I'll check how many combinations are there, and I'll add all those combinations. Yes, I think this might work. Exactly, this is totally possible. It's just I need to be sure there will be like lots of combinations which I need to handle. So 10 to the power 9 plus 7. Yeah, this can be like possibly done. You think that this the way I'm thinking is correct, Alex? Like this will go till 800. Everyone, I'll check whether it is possible to reduce it down to k to to 1 in k operations or not. That will be like 5 iterations, and then I'll do the combination formula. I'll apply the combination formula, which is I suppose like combination is 5 factorial by 5 minus 1 factorial 1 factorial. Yes, this seems, so this is like the combination formula that I need to like handle. There's a lot of implementation details. uh, Implementation detail, I would say, is not that complex. Only I need to know like how to find the combination. Need to handle leading zeros, for example. mm. Yeah, it might be possible that there are leading zeros. So I need to check will there has no okay, and there is constraint that it has no leading zeros, so it's fine. As consist of only characters 0 and 1 and 800, so there are no leading zeros. So I think whatever the size of the array will be, that will be only one edge case. What currently I'm thinking is, if there is only one set bit, like this example, if we take this 1000, so we have 1 2 3 4 4 C1. It's like, should I go till 4C4? No, I should go like till 4C3 only. 4C1. Will there be like that kind of edge case for this? Alright. Okay, not a problem. Thank you very much for the ideas. One more thing, like, can you connect with me on LinkedIn? Maybe I'll ping you my LinkedIn profile once. So, okay, just a second. Here. Okay, so now I need to know 5 factorial by 4 factorial, 1 factorial will be 5. So combination formula, this is something I need to know, and rest is, I think, will be possible. Okay, let's try it. Int n is equals to s dot okay, let us see. I need to start from number, like start from 1, go till n. Like combination formula C++. Is NCR. Give a virtual contest in Codeforces, please. Division 2. Okay, I will try. Not an issue. I am. Excuse me. I'm sorry. Actually, I'm still learning. It's not something that I'm very good at. So I'm not sure how much question I'll be able to solve on Codeforces, but I'll try. So I'm trying to solve this question. After this, I'll try to come up with the Codeforces contests. So there's some logarithmic formula for calculating the NCR. Okay, I'll need to have a look at this NCR formula. Okay, for now I'll take that formula just in order to check whether my logic is correct or not, and I'll have to understand that NCR logarithmic formula also. That is also good. So for int I is 1, I is lesser than n plus I. So this will do what? For everything I need to check whether it is k reducible or not. Okay, so if is reducible I, if it's reducible I will like check. It will return bool is reducible integer value. Now if it is reducible, okay, if it is reducible, suppose we got true, I need to find the combination, how many combinations are possible. For that I need to have this NCR. Okay, let me check. I will take it as long for now. Number and I round expression. Don't convert it into, if it is possible I will like take long result as 0, and I need to take kind of mod 2 4 5 6 7 8 9 plus 7. So if it is reducible, whatever value will get, so answer is equal to answer plus NCR. N and I combinations I want. Will be added moduloed with mod. Okay, now whatever we will get will return the result. Now is reducible. Now the something I need to check is reducible, this val. Now while val is greater than 1, okay, val is equals to built-in, I suppose this built-in pop count of val, and I need if times is lesser than or equals to k. Sorry. I need to pass k also here. Okay, let me check. Okay, I haven't taken K. Times. Okay, nice silly mistakes. Come on. Okay. Why it is 6? Like all the combinations of like 2 digits. So like I have value is 2. So if we have like 2 in one step, the count will be reduced. So like we have a number as 3. So in one step the count will be like reduced to 2, and in another step so like 1 is possible, 2 is possible, 3 it should not be. Okay, why? What are we getting from is reducible? If I'm taking the number as 3, uh, the number as 3, I is 3, and k reducible. Let me print val and times. So maybe I'll start with 1 directly. How it's like So 1 2 like 4. Okay, there is some few edge cases. Mm, mm. I would say, what is the value that we are getting from NCR? uh, Counts. Okay, we have counts times. We don't do endl. We just do space. Let's see. Okay. For one combination, we have like for two, uh, we have uh, six possible combinations, but the numbers are like higher. The the count of bits. Okay. So there's one more thing. If like the bit count should not be like greater than. So total bit count should not be greater than the number, and bit count that we have in the string. That is one thing. Like it can be. It's possible it can be like greater than. So if we have two, so I can like three is like greater. It's possible. Uh, what edge case are should we have to handle? Do we have to handle here? After this question, please see if. Okay, sure, Vedan. I'll do it. Uh, I'm just thinking of the edge case. What is the possibility of handling the edge case here? I have like 1 2 4 8. This is like 8. I need to like know the position also. What is the last set bit? If a current number has a set bit of last, like doing direct combination, there will be like, there are edge cases, lots of edge cases that I need to handle. Okay. Hmm. Is it like correct way? Is this the correct way to solve this? Even the only thing is like the last number. So maybe I can reduce it. And for last bit set, there I need to check like if I can like reduce it one more. And for the last bit, I check it separately. No. I'm only saying that okay, we have four, we will be doing three. So instead of like n, will should we go till n and here? Okay. Yeah, we went till like n minus one, but this case will fail because we are missing one. So the last set bit, if it is like set, so set that bit. And now how much bits are there? Like that. No, this is something I need to handle. If I set the last bit, if this bit is set, it might be possible that this bit was set. Now if I do combinations, it will not be possible. For the last bit we need to do something. We need to check something. I'm very close to answer. I did for these three. So like and minus one, I should go to like till from one we had four, so lesser than four will go like till three only. So it's fine. This is fine. uh, 3c, we are only working on this. Now if this bit is set here, I need to handle the last case. If this bit is set, what do I need to do? I need to start from here, here and here. And what if this bit was set, this and this bit is set? Now I cannot set a bit here. In this case, we have 1010. For last, I cannot set a bit here, like 111 or even 00 is not possible, but this will be like a number greater than this. So this is like should not be, shouldn't be the case. I need to find uh, I can only like change this from 0 to 1. No, that will also increase the number. So beyond this bit, if I set this bit to 0, I can do all the combinations here. 1 0 0. This can be like 1, this can be 0 if I'm setting this, because this number will be like smaller than 1010. Now if the number was 1100, what would have been the case here? What is a possible number? Like, I can set this bit at 0 and do all the combination here with rest of the bits, then the numbers will be smaller. Now I can set this bit as 0 then, and then do all the combination over here. Possible, right? And then I can set this bit as 0 and do all the possible combination here for the rest of the string. So maybe this can be like done here also. So if we have like 1 1 1, set this bit as 0, and after this do all the possible combinations. There's no number. Now we found another one, set this bit and 0 and do all the combinations here. So what all combinations will be there? Like we have 1 and 1c 1 operation 1, and one more for this. So a total of 2 till now, and I set this bit as 0 and do all the combinations over here. Huh. 2c 1 will be like 2, 2c2 will be like 1. What is happening? Why? Sorry Vedant, but it is taking a little time. I don't know. If you have something in your mind, you can surely tell me, but I want to solve this question. I'm very close to answer, I would say, and I need to know like how to handle the only case that is the last case. If you have something in your mind, let me know. This is the only case when I have this last bit set to 1. Now if this last bit is set to 1, and then I don't have any bits here, right? I need to find all the possible combinations which are like smaller than the given number. with this as this bit set. This is what I want. All the combination of numbers with last bit as set, or always bit as same. So like how many, what is the possibility? Maybe I'll take a bigger number, 1000000. Suppose this is the number for the last bit. For rest of the bit, I'm simply handling the situation. It's fine. For the last set bit, I need to handle. If I take this test case 001 and case, suppose like we have 5, we are not having any bound. Well, obviously it will give me wrong because I haven't calculated the last possibility. I need to know like what is the difference. So it's 1023 is the possibilities and 1155 is the maximum. So there are possible numbers which we can draw from here. Now if in case 4, if I do this also as 0, then how much combinations we can draw? This reduced to 1151. So like this was 0, it's like I am saying how many possibilities are there to these combinations make setting this number as 0. Like if I set this number as 0, I can do anything on these numbers. It'll never go beyond this. Is it 100? This is like 4. I can do any operation on this. I'll set this as 1. Even that'll be like 3 only. That is like the smallest number possible. So I need to like find the second number where 1 is. Means after this, wherever the first one we encounter, after that all the bits can be like, assuming that I am setting this bit as 0, and do all the combination for rest of the string, same combination formula, count k reducible number. So for 1 2 3 4 5 6 7, 7c1, set everything to 1. But there will be some common. 7c2, Oh my god. 7c3, 7c4, one, but this will take like 7c5, 7c6, and 7c7. How many combinations do we have with this? 1, 2, 3, 4, 5, 6, 7. Okay, like 127 combinations we have. So 1023 plus 127. That is like 1150. Where is I'm like missing one case? Where like I'm setting this number as 0. Is it? Yes. Actually, I'm just stuck with an edge case on this. I just wanted to like solve the edge case. Just give me some time. After this, I will do Codeforces. Don't worry. Just give me once. Okay, we have this as set, but this will like obviously going to be set. After this, I find a position, but this should like why it is 127. This is what I'm little skeptical about. I have all the possible combinations. If I set only this as 1, what will change? If I set this number as 1, what happened is 2 more combination added. How 2 more combinations added? If I set this as like 0, I can set this as 0 and 1. There are 2 possibilities for this number. 1, 2, 3, 4, 5, 6, 7. How are you this good? How many months have you been practicing? Uh, I would say I'm not really good. First thing, like yeah, I have been practicing like from my college time, like end of my college year. From maybe like last semester, I started preparing for my placements. So it's been like kind of 1.5 year or so, nearly. But still, I would say that I'm not really good. There are lots of people who are way better than me. I'm just trying to improve in on this. I think you must be good now if you're asking for a virtual contest of Division 2 on Codeforces. I guess you'll be like good. I'm not at all good. I can solve medium level questions, but hard level questions are little more trickier, which always slips from my mind. So if this was like 1 1 1, I can like keep this as 1, make this as 0. So if I make this as 1, this is one possibility, make this as 0. This is one possibility. So like two combinations. Possible. Now if I like set this as 1, how many combinations will be like? If I set this as 1, what happened is like mark this as 0. I have 2, so 2c1 and 2c2. So 2c1 will be like 2, 2c2 will be like 1. So in total of 3 plus 1 for this making like, so total of 4. So plus 4 is like, and if I do 101 over here, like will this change my answer? If this is changing my answer, I need to think. Okay. Okay, just give me a minute. There is someone at the door. I'll be back in a minute. Okay.
दोस्त उसका कुछ सामान लाया था वहीं से घर से, तो वही लेने गए थे उसको। कैमरा ऑन हो गया क्या? बताया तो कर।
कोई बात नहीं।
थोड़ा सा आया।
थोड़ा सा आया है। Okay. After this, try this Codeforces 977 div 2 based on compfest. On see a filter of virtual contest base. Okay. Maybe what I can do is like I can hit and trial and do lots of stuffs, and then I can like try to figure out the answer. Only once I'll try this, else I'll look into the solution for this. This was one. I what I did is like I made this as 0. It's like 2c1 and 2c2. But one more is possible. Why it increased to one more possibility? My answer is same, right? Test result is 127 only for this. For the last one, it's something figuring out is a kind of a, if I do set this as 1, it's not possible. Okay, the one is like I set this as 0 and do all the combination for the rest, and whatever the output is +1. Okay. So it's the pattern is something like this. If I make this as 1 0 1 0, right? Once make this as 0 and do all the combination for the rest +1. Make this as 0, do all the combination for the rest and +1. This will increase, right? Why it increased, I'll tell. I can say that 1 0 1 0 1 0 1 0. If I first try to set this bit as 0, what all combinations can I do? Three C1 plus 3C2 plus 3C3, right? Okay, 3C1 is 3, 3C2 is like 2 factorial 3. Again, I think 3C3 is 1. Now I kept this as 1. I made this as 0. And for this, there are like one either I can make this as 0 or 1. So 2 combinations possible. +1, let's see. 10. 3 plus 3 6 7 8 9 and +1 for this. This one was like 1c1 was 1 plus 1, that is 2. Okay, so this is what is happening. 10 is added and it will be 127 to 137. Now for this I just need to understand this should not be like wrong. 1 1 1, we have this as 1. I found this as 1. Now how many possible combinations can I do after this? So will it change? It added one more and make that number 0. I made this number as 0. That will add one more in my answer, that is 1. And for this, like we can why it's 2 and expected 3. There is something like for the last case only, edge case only, we are somehow okay. Digit DP. It was like kind of looking to me like a DP only. Pick and non-pick part. Let's say it's a pick and non-pick. I'm not sure. Hello, Aradhya Verma. String length is at most 800, so the total number of set bits can at most be 800. So why not pre-compute the k for each number up to 800 they would need? Hi, it's Kundan, not uncle. When if you are Aradhya, then it's Kundan. As now we have pre-computed this using digit dp to find out the number of solution. That we have not gone below our initial string up till now. Set bit stores the count of set bits seen up till now. Open pal world. No. Currently I'm studying. So what I'm doing is like from 2 to 800. Eight zero one. Y plus 1. How many built-in pop counters? Why we added 1? dp of I tight set bits is equals to result. Tight set bits equals to 0 0. What I am doing? Why he is doing something like this? What is this tight? Tight means that we have not gone below our initial string up till now. First we prepare a DP. DPI means the number of operations to reduce from I to 1. I dot bit count plus 1, and we initialize DP of 1 as 0. Then we iterate when we meet 1, we set this bit as 0. then the numbers will be smaller than s, whatever the suffix is. Exactly, this is what I was thinking. If I set this bit as like 0, whatever the suffix is, uh, I'm damn sure that all the numbers will be smaller than this. C1 is the count of 1 that we met in prefix. C2 is the count of 1 that we will put in the suffix. C1 is the count of 1 that we met in prefix, acha, okay, and C2 is the count of 1 that we will put in suffix. We check if k reducible. dp of C1 plus C2 plus 1. We check if k reducible, then we update the number of combination comb. There n minus I minus 1 bit is the suffix, and we'll put C2 of bit 1. Finally return result. Given a binary integer as, just a second.